Our second category of ionic compounds are those that contain polyatomic ions. First of all, you're going to need to memorize your polyatomic ions if you haven't already. Remember, they can be found in section 3.7 of your textbook or notes. So when a polyatomic ion is part of a formula, then we're just going to write the name of that polyatomic ion as is. We are not going to change the ending to IDE. The IDE ending specifically refers to an individual type of atom, whereas the polyatomic ions have multiple atoms in them. So for example, AlPO4 is aluminum phosphate rather than aluminum phosphide. Aluminum phosphide would only have phosphorus on the end of it with no oxygens. What is the correct systematic name of NH4,2Cr2O7? Keep in mind that the polyatomic ion containing ionic compounds are going to be named basically the same way as the simple binary ionic compounds, but with not changing the ending of the polyatomic ion. Is the answer A, sodium chromate, B, ammonium dichromate, C, diammonium dichromium heptioxide, or D, diammonium chromate? The correct answer is B, ammonium dichromate. There are two different polyatomic ions listed in this compound, the ammonium ion, NH4+1, and the dichromate ion, Cr2O7, 2-. We name the first ion as is, since it's a polyatomic ion, and we name the second ion as is, since it's a polyatomic ion. So the name of our compound is ammonium dichromate. It is really important to memorize your polyatomic ions so you can recognize that Cr2O7 is the dichromate ion, and not just guess something like dichromium heptioxide as its name. Also, notice that the subscript of 2 on the parentheses outside of the ammonium did not become part of the name. This is for the same reason that it is not included in the name of simple binary ionic compounds. We are just listing types of ions. This compound contains ammonium ions and dichromate ions, so it's called ammonium dichromate. Polyatomic ions are ions that contain multiple atoms, and those atoms are stuck together covalently, kind of like glue. They're not typically going to be broken apart over the course of reaction. These polyatomic ions act very similarly to the single atom ions that have the same charge. For example, phosphate, which has a -3 charge, is going to act very similarly to nitride, which also has a -3 charge. Just like with nitride, sometimes we need more than one of them in order to make our compound neutral. When that's the case for a polyatomic ion, we're going to need to surround the polyatomic ion in parentheses, and then put a subscript on the outside to indicate how many of that polyatomic ion we have. So for example, with Mg3PO4 we have 2 phosphate ions. Notice we're not writing it as P2O8, but we're going to keep that PO4 as its own individual unit. And then the parentheses with the 2 tells us that we've got 2 of those individual units. If you want to go from the name to the formula of a polyatomic ion compound, again, we're going to need to know the charges of the ions. So let's say the compound's name is calcium phosphate. We know that the calcium is going to be a +2 because it's in group 2A. For the phosphate, you'll need to know the charge from memorizing it. In this case, the phosphate has a -3 charge. After figuring out those charges, we do the crisscross rule. We figured out that calcium is a +2 charge, and phosphate is a -3 charge. When we crisscross, the 2 from the calcium goes down next to the phosphate, and the 3 from the phosphate goes down next to the calcium. Notice that we've put parentheses around the phosphate before putting our 2 next to it. Again, the reason why we're doing the crisscross rule is to make sure our ionic compound is neutral overall. We've got 3 calciums, each with a +2 charge, making a +6. And then we've got 2 phosphates, each with a -3 charge, making a -6. Again, +6 minus 6 equals 0. What is the formula of calcium hydroxide? Is it A, CaOH, B, Ca2OH, C, CaOH2, or D, Ca2OH2? The correct answer is C, CaOH2. Calcium has a +2 charge because it's in group 2A. Hydroxide has a -1 charge, which we know from memorizing our polyatomic ions. The 2 from the calcium goes next to the hydroxide on the outside of some parentheses, and the 1 from the hydroxide becomes an understood 1 next to the calcium.